Alright, if you've been going through the MOEA framework videos, you probably have figured out how to set up your own problem with MOEA framework, and you probably ended up with something in your Java file that looked like this. So we were calling the executor class here. We tell it what problem to use, what algorithm to use, how long to run for, and then down here we say run. Okay, and then print the results below that. So when you do this, it's only running for one random seed. So because it's a heuristic search, all of MOEAs are heuristic search methods, they can be sensitive to what random number or what random seed you use for your random number generator. In other words, they're randomly choosing solutions, and sometimes those could be good or bad. You don't want your algorithms to be sensitive to what random seed you use. So to check that, you usually have to run multiple random seeds to confirm that it's robust across different random seeds. So in MOEA framework, one way of doing that, the built-in way, I guess you could say, is instead of calling run here, you can call run seeds and then pass in a parameter like 20 if you want to run 20 seeds. The problem with this is that it expects it all to finish in one job submission. So if you have a very fast function evaluation in your evaluation function, this would be feasible, but usually for larger models you can't really do 20 replicates of these large optimization runs in a single cluster submission. So the way that I came up with a kind of ad hoc way of solving this problem. So in the main part of your Java file, I've added in this block here, which was not in the previous video. Basically the idea is you can pass in a random seed from the command line, and then we can loop through a bunch of random seeds and submit jobs to the cluster queue for each of them. That's the general idea. So here we're declaring a long double called seed. If there is a command line argument passed in, then we're going to parse it as a double and assign it to seed, and then we're going to do prng.setSeed. So what is prng? Up at the top here you'll see we're importing MOEAFramework.core.prng, so it's the pseudo random number generator. It's a built-in class in the framework, and you just give it a seed and it serves all of your random number generating purposes. And of course if the user tries to send in text instead of a number, then you exit with an error. But so setting the seed here will affect the entire evaluation run. So that's the basic idea. Quit? Okay. Let me look at my files here. So what I was saying before is now you can loop through cluster submissions pretty easily. So before we were submitting only one job, and here I'll show you how you can submit multiple random seeds as different cluster processes, and that's the key. So they're not running sequentially. They're all going out as separate jobs, and theoretically they would be running in parallel, hopefully. So this is just a bash script designed to loop through these things. So the important thing is here you say how many seeds do you want to run. Here I'm saying 50. If you have other arguments to pass in, like what algorithm you're using or so on, you might want to handle that here. You can create an array called seeds, which is a sequence, I'll use the mouse, a sequence from 1 to seeds. If you want to use seeds that aren't the actual numbers 1 through 50 or whatever, you can do that too. Then down here we're going to loop through, well here it's looping through different algorithms. I'm only using one algorithm, so it's not that critical. But here's the important thing, we're looping through the different seed, we're saying for seed in the array seeds. We're going to come up with a name for the job called algorithm problem seed, and we're going to echo the fact that we're submitting that to the cluster. Then the key comes down here. Let me see if I can get this in the, oops, that didn't work. Okay, I'm just going to move this here if I can do that. You can't do that. There we go. Sorry about that. Okay. I had to resize my window. The key here is we're building a string called PBS. So every time through the loop, we're going to assign a string called PBS to the following. So if this looks familiar, it's because this is what a PBS submission script looks like. So previously, we were creating these submission scripts in separate files, and then you'd have to submit all of the files individually. But all a PBS job really is a string. It doesn't have to be in a file. So here we're building that string. We're saying we're using the bash shell. The job has this particular name. We're requesting this many nodes, this wall time. We're going to send output streams to this directory, error streams to this directory. Then of course you want to cd to the directory where the job was called from, and then finally you will call your optimization problem. You're going to say Java, whatever the arguments are, the name of your compiled Java class, and then you're going to pass in the seed as a command line argument. The idea being, of course, here you're looping over the array seeds. So here it's 1 to 50, and then you'll pass in 1 to 50 here into the problem class. Then you take the string PBS and echo it and pipe it to the qsub command. So instead of qsubbing a file, you're going to use qsub to just submit a string to the cluster. And it's usually a good idea when you're doing this to have a little delay in the loop, because you're not going to miss half a second, but you might get yourself blacklisted or something from the cluster if you're firing off jobs as fast as humanly possible. Then finally, when it's done, it'll tell you that it's done. Okay? So that's the idea behind submitting multiple random seeds. There might be better ways of doing it, but this is the way that I've been doing it, and I think it works pretty well. Alright, thanks for watching.